Hi, today I'm going to talk about facility location problems, specifically the P-sensor or Minimax models in operations research. This topic is about finding the best locations for facilities like hospitals, warehouses, or fire stations in order to serve customers efficiently. Here, the important thing is that we focus on the facilities where the response time is important, like an ambulance or a fire station. So what's the P-center problem? The P-center problem tries to minimize the maximum distance between customers and the facilities. So we focus on the customer who is the farthest away. The goal is making sure that even the farthest customer can still receive service within a reasonable distance. That's why the model is also called the Minimax model, because we actually minimize the maximum distance. This approach is useful for emergency systems, like I said in the other slides. Now, unlike covering problems which try to minimize the number of facilities, the P-center model focuses more on fairness and equal service quality. There are two main types of P-center problems. The first one is continuous P-center problem, where the facilities can be located anywhere on the network, including along edges or at any points in the solution space. We usually solve this model with mathematical models. And this model gives us more flexibility and can produce better optimal solutions. The second type is vertex P-center problem. Here, facilities can only be located at existing network nodes or vertices that is certain before. This one is more practical in real life because companies often have limited possible locations for service centers. Now let's look at the absolute one center algorithm. This algorithm helps us find the best location for a single facility on a tree network. Firstly, we pick any point on the network and find the farthest vertex from it. And this point is called E1. Then, starting from E1, we find another farthest point that we call E2. These 2 points create the longest path in the network, and it's known as the diameter of the tree. Finally, we find the midpoint between E1 and E2. That midpoint becomes the absolute one center because it minimizes the maximum distance to all other vertices. If the midpoint is not exactly on a vertex, we choose the nearest vertex. Here we can see an example of the one-center problem. The absolute one-center is located between nodes G and H, and this solution gives the minimum maximum distance, which is 20.5 units. However, if we restrict the facility to existing nodes only, then node C becomes the best option. And this is called the vertex one-center. Its objective value is 21 units, which is slightly higher than the continuous solution. So this example shows us that continuous solutions are usually more efficient. However, vertex solutions are more realistic. Now let's move to the absolute two-center algorithm. This model is used when we want to place two facilities of one instead of one. Firstly, we find the absolute one center. Then we remove the arc containing this center, which divides the network into two similar subtrees. And after dividing the network, we apply the one-center algorithm separately to each subtree. And as a result, we obtain two optimal facility locations. Using two facilities can significantly reduce travel distance and improve service quality. To conclude, the P-center minimax problem is an important optimization model in operations research. The main objective here is minimizing the maximum distance between facilities and demand points. Today we discussed the minimax model. Thank you so much for listening.